Today's notes are brought to you by Inspirational Quotes. So this one says, "You can never cross the ocean unless you have the courage to lose sight of the shore." Our title is 10-6, Circles and Arcs. And this is what our notes are going to look like today. There is a glue-in, and you are going to need 2 markers. So we're going to start today by drawing a circle. And these are the different vocabulary words that we're going to put on the circle. In red, we're going to label the radius, diameter, center, and what a central angle is. And then I'm going to show you a minor arc and a major arc. So here we go. Let's start off by drawing in red the center. So the center is basically the center point of the circle. The radius goes from the center, has to go from the center to the edge of the circle. And a diameter would go through the center from edge to edge. So let's go ahead and move that stuff over. So the radius, let's see if I can get this on there. There we go. Here's my radius. My diameter is this long line right here. The center I'm going to leave over here, and I'm going to just draw a line there. And now a central angle is related to the center. So a central angle is an angle whose vertex is at the center. So I'm going to go ahead and call this, I'm going to label this A, B, and C. So angle ABC, this angle right here, is a central angle because its vertex is on the center B. So I'm just going to call this a central angle. Okay? Now let's start labeling some arcs. Now an arc is basically the crust. Oops. Let me grab my thing here. The arc is like the crust of the pizza. It's the edge. So let's go ahead and talk about this. So in blue, we're going to call AC an arc. So AC is an arc. And on the flip side, AC could also be this arc out here. So how do I know which is which? Typically, we would add an extra letter in here. So let's make this letter M. So I'm going to call the smaller arc AC. And the arc symbol is like literally a little arc. So AC, the little AC, would refer to this section here. Now if I wanted to talk about the larger arc AC on the other side that goes by the letter M, I would call that the major arc. The major arc would be arc AMC, and I'd put a large arc there. So that's the difference between a minor arc and a major arc. Okay, now in the space that we labeled example 1, I'd like you to pause the video and write in a couple things before we do any math. The first thing I want you to write is this question: how do you find the arc measure? And when I say arc measure, I'm talking about something specific. I'm talking about how do you find the measure, the degree measure of an angle. That's how much it rotates from here to here. I'm not looking at the length, I'm looking at the degree measure. So that's an important difference. Later in this video, we'll learn how to find the arc length, not the arc measure. So I'd like you to copy this diagram and then this sentence down here. Here's what it says. The measure of an arc is the same as the central angle that defines it. Go ahead and unpause the video when you're ready to answer some questions. So you should have all of this copied down. I'm going to go ahead and move our little inspirational quote to the corner, and we're going to take a look at these questions right here. So they've asked us to find the measure of arc BC, BD, major arc ABC, and minor arc AB. So we've got 4 arc measures to find, and I know they're asking me to find a measure because of this little M here. So my answer is going to be a number. So it says, the sentence that you wrote is the measure of an arc is the same as the central angle that defines it. I'm going to change my marker to a lighter color. Here we go. So let's start with BC. First I'm going to find it. Now BC is this arc right here. Now this arc is defined by the central angle whose endpoints are right here. So it's created by angle, central angle 32 degrees. So the measure of BC is 32 degrees. And you can see that because this angle creates this arc. It defines that arc. The next arc they ask us to find is the measure of BD. Now BD goes all the way from here to here. So BD is this arc. Now that should be pretty easy because we just learned that this is 32 degrees. So if they want us to find this entire measure, then it's going to be 32 degrees plus 58 degrees, which is 90 degrees. Okay, so all I did is I added these two together. The next arc they asked us to find is the measure of major arc ABC. I'm going to start from A through B to C. That's this entire mark right here. I want you to notice something. I know this part is 32 degrees, but I don't know how much this is. But if you're really observant, you should notice that the central angle that creates arc ABC is this line right here. And the degree measure of a line is 180 degrees. That means that this arc right here, this arc measure, is half of a circle. So half of this circle then is, well, 180 degrees. So without knowing that little part right there, without knowing this arc, well, I didn't need to know it. I'm still able to find this measure because I know this central angle is 180 degrees. I'm actually going to mark that right here. So this angle right here is 180 degrees because it's a straight angle. The last arc they ask us to find is AB. AB is this section right here. Now that's easy to find. I know this whole section is 180, and I need to take out this part right here, this 32 degrees. So if I take the whole 180 and take out this portion, I should get arc AB. So that's going to be 180 degrees minus 32 degrees. Well, how much is that? 148 degrees. So that's how you find the arc measure, specifically always looking at the central angles and the relationship with the arcs next to it. Now moving into example 2, again I'd like you to copy down this circle with this radius of 4 with this title, how do you find the circumference? So the circumference in this case is the measure around the circle, the measure of the length. And this is a formula you know already, circumference equals 2 times pi times the radius. The first thing we're going to do is find the circumference, and that's relatively easy. The circumference is 2 times pi times the radius, which is 4. Now the nice thing here is we're always going to leave everything in terms of pi. So the only thing you're going to multiply is 2 times 4, which is 8. So we're going to say the circumference is 8 pi. But now I'm going to ask a more important question. If you can find the whole circumference, then you should be able to find part of the circumference because it's going to be some value less than 8 pi. So how do we do that? So let me move this guy out of the way. And now I'd like you to add these extra points and values on here. Let's call this A, B, and C. And I'd like you to put in this point M here. And we're going to find a couple values. The first thing I'm going to ask you is, can you find, and I literally want you to write the length of arc AB. So can you find how far it is from, I'm going to call this question 1, from here to here. And then my second question, let me change back to red, is can you find the length of major arc AMC? Okay? So let's go ahead and talk about this. If you want to find the length of a part of a circumference, then you need to know how much of that part of the entire circle it represents. So I want you to copy this down. Let me change this to purple. Here we go. So here's how you're going to find it. If you want to find part of the circumference, here's how you do it. You're going to take the fraction of the circle. So how much of the circle does it represent? And then you'll multiply that by the circle. Circle circumference. So what you're really asking is, what portion, what part of the entire circumference does AB represent? So let's try that out. First, we're going to find the fraction of the circle. So for the length of AB, first let's ask ourselves, how much is AB of the entire circle? AB represents 40 degrees of the entire circle. So that's 40 degrees out of the entire circle. How much is the degree measure of a whole circle? That's 360. So it represents 40 degrees out of 360, and that is 1/9. So that represents 1/9 of the circumference. So we're going to take 1/9 and multiply it by our circumference, and that'll actually give us, I'm going to make this a little bit smaller, that'll give us our circumference of just that blue portion. So if I multiply 1/9 times 8 pi, I get 8 pi over 9. And that is the length of AB. Okay, now let's try to find the length of AMC. The first thing I need to do is find the fraction of the circle. AMC covers this whole amount. Well, that's 40 degrees, 20 degrees, and how much is this half circle? Well, I said it in half circle. It's half of a 360, or 180 degrees. So let's see, that's 40 degrees, 180 degrees, and 20 degrees, which makes 240 degrees. So that means that we have 240 degrees out of, that's whole 360 degrees. What fraction is that? Let's do some mental math here. First, take out the 100. So that's really 24 divided by 36. Divide by 12, and I get 2/3. Okay, that's 2/3. That means that this section of the circle, it represents 2/3 of the entire circumference. So that's 2/3 times 8 pi. When I do my multiplication, I'm going to do 2 times 8 pi. That's 16 pi divided by 3. And that is the length of arc AMC. For this last question that you glued in, I'm going to have you do most of this on your own, but I'm going to help you think it through. The question says that there's a 2-foot wide circular track for a camera dolly. So this section is 2 feet. The radius of the inner circle is 8 feet. How much farther does a wheel on the outer rail travel than the wheel on the inner rail? Which is the same question that's right here. So question 1 is, how much farther does a wheel on the outer rail? That's a wheel that travels on this section. How far does that one travel? How much more does it travel compared to this wheel? Now my strategy would be to find the circumference first of the outer rail, and then the circumference of the green rail, and then subtract them. So that would be my strategy for that one. For question 2, it says, if the camera dolly travels from point A to B, how far does the inner wheels travel? For this one, I want you to note that from A to B, it's traveling 1, 2, 3, 4 sections. Now imagine that this radius continued through. If it did, this line would represent half of the circle. So from A to here is half of a circle, 180 degrees. 1, 2, 3, 4, 5, 6, 7, 8 of those lines. But from A to B, it only goes 1, 2, 3, 4. I hope that hint helps you find out what degree measures here and what degree measure are both of these arcs right here. So please think about that. And again, I don't want you to leave your tier until you've answered questions 1 and 2. Feel free to work with a partner.